breakfast this Saturday, and I was wondering if you could pick up a few breakfast foods like fruits like apples and oranges. If you can, that'd be great. Awesome, I'll see you then. Oh man, that's not going to be enough. So many more teachers RSVP'd. Hey Lacey, it's Beth. We're having that teacher breakfast on Saturday, but so many more teachers RSVP'd and I don't have enough breakfast fruit. Do you think you could pick up some more apples and oranges for me? Maybe about 10 more? Thanks, that'd be great.
So I don't know if this is enough fruit.
Oh man, I don't think it is, but that's okay. I'll go get some more later.
Okay, well I spent $2. Can you put that in the budget?
Yeah, definitely.
Okay, thanks. See
See
you
you
Saturday.
Okay, let's see. Since I'm on a budget, I need to figure out which fruit costs less and go back and buy some more of that one. So Tanna bought 4 apples and 2 oranges. She spent about $2.50. And Lacey bought 5 apples and 1 orange and spent a total of $2. So I think I can solve this out using a linear system of equations. So here are the equations that we need to figure out the individual prices of apples and oranges. Here we're representing x as apples and y as oranges. As you know in class, there are 4 different methods for solving linear systems of equations: elimination, substitution, graphing, and matrices. So let's start with elimination. In elimination, we need to be able to eliminate one of the variables to solve for 1, since we have 2 unknown variables here. So we'll start by multiplying each one by something to where we can eliminate. We'll work on this one right here because it's easier to multiply this equation by -2 to eliminate the y variable. So we'll multiply the entire equation by -2. When we do that, we get 4x plus 2y equals 2.5. And we get -10x minus 2y equals -4. Now we'll try to eliminate the y by adding them together. And we are left with 25 cents. Now we're going to plug this equation back into one of our systems to solve for y. So we'll plug it back into the top equation. We'll get 4, plug in the 0.25 for x, plus 2y equals 2.5. And we're left with y equals 75 cents. So here our apples, which are x, equal 25 cents, and our oranges, which are y, equals 75 cents.
Okay, our next method that we can use to solve linear systems is substitution. So in substitution, we would like to solve for one variable and then substitute that into the other equation. So in these equations that we are given, it's very easy to solve y by itself because it's already a single variable. So if we subtract 5x over, we would get y equals negative 5x plus 2. So now that we have y by itself in this equation, we can go ahead and substitute that in for the y given in the other equation. And we get our x to equal 0.25. So now that we know what x equals, it's really easy to plug this back into the equation where we got x by itself. So once we do that, we have y equals negative 5 times our x value that we know is 0.25 plus 2 and so y therefore equals 0.75 or 75 cents.
And so now we'll try graphing it using the quick graph method to find the x and y intercepts of each line. First, let's graph the top equation, starting with the x-intercept. To do this, we'll cover up the y portion of the equation and solve for x. When we cover up the y portion, it leaves 4x equals 2.5, giving us the x value in the x-intercept as 0.625. And then we solve for the y-intercept, covering up the x portion, giving us 2y equals 2.5, leaving the y value in intercept as 1.25. And then we'll connect the dots for the line. Then we'll do the second equation, following the same pattern. We'll cover up the y portion. The point where both of the lines intersect is 2575, right here, and which we know is the only solution to our linear system since that's where they intersect. And when we write linear points, we always write the x value first and the y value second. And now we know that our apples equal 25 cents and our oranges equal 75 cents.
Our last method is using matrices. Remember that the matrix A is the matrix of coefficients of the variable. So from equation 1, we would have 4 and 2. And equation 2, we would have 5 and 1. Matrix X is the matrix of variables, which are x in our case and y. And matrix B is the constant matrix, which is 2.5 and 2. Remember that they have to be aligned with the equations. Let's recall how to solve for capital X. If we have A x is equal to b, we need to get rid of the a by multiplying by its inverse. Remember though, we have to multiply by the same side. That cancels out the a and leaves us with x is equal to a inverse b. We know that we can put this into the calculator. Let's enter matrix A. Now let's enter matrix B. We need A inverse times B to solve the system. So we can see the solution is x equals 0.25 and y equals 0.75. As you can see, each method produced the same solution.
So it looks like on my budget, I need to just go buy some more apples.